Now what we've got here is we're supposed to predict the number of calories in a candy bar that weighs 62.3 grams. And as you recall, at the very beginning, the problem statement shows that that the data that we put in L1, where the x values was the weight, so the x stands for the weight, and the output of the linear function is the calories. So when you plug in a certain weight in for the regression equation, that equation of that line we came up with, if you put that in for x, any weight, then you will be predicting what the calories, the number of calories that that candy bar will have that has that weight. So basically our calculator can do that for us because it has stored this regression line, this line of best fit equation, in y1. If you go back to the calculator and you hit y equals, you'll notice it has an equation stored in there. Now don't change it or delete it to keep it in there. But let's go back to the graph here. And now if we want to enter a specific x value and have it calculate what the y value is, then basically all we need to do is let's see, in this particular case we want to enter in 62.3 for x and then have it calculate y for us. So to do that, we're going to go second and then calc. Second, calculate, which is the trace key. So second trace key gives you the calculate menu, and we're going to choose option 1, which is value. And it's asking us at the bottom here for an x value. So we're going to type in 62.3 and hit enter. And it gives us a y value down there at the bottom of 277.23. And that actually would be the number of grams that it estimates that the candy bar will have, or excuse me, the number of calories that the candy bar will have if the weight of the candy bar is 62.3 grams. So we'll just put this graph on top of here, and so the answer to this part E would be, well, predict the number of calories in the candy bar that weighs 62.3 grams. That would be 277.23 calories, or 277 if you want to just round it. So that's the answer to that. And then the last part is interpret the slope of the line found in part C. Well, let's copy this regression equation here to this last part. And remember, the slope is the coefficient of x in this linear equation. So it's a. So a is 2.8836. So interpreting that means basically, since the slope is equal to the rise over the run, in this case the rise or the y value is equal to the calories, and the run is the x values, which is the grams. Okay, so if the slope is equal to the 2.886 calories over 1 gram, then that means basically for the interpretation would be, and this is the answer, for every increase in weight of 1 gram, the number of calories increases by 2.886. So that's the interpretation of the slope. Okay, and that ends the whole problem. We're done.